Yeah, no, when I took the loose hand, I sprained my mouth.
I like it like this.
My heart's racing.
No, it's actually 100 something. I just don't remember.
Yeah, they did.
I found my warranty.
My heart's racing.
Stop drinking Monster.
Do you want
It's not monster.
Okay, awesome.
It's just caffeine.
Then I will close that up. This is
Actually zip
your
filed
lovely
all
place.
of the lesson plans for Dr. Smith.
Okay.
She was impressed with my ability now, which is not a big deal. Is there a plug back here?
There's one over here that I can
I don't
connect
think
to.
it will go.
Let's see if it'll go.
I don't
You
really
can
know.
always slide the desk. Yeah, it needs a little bit more. Got it. Boom, you're in.
I just paid.
Okay, I got this right here. No, I really have it.
I'll turn it off.
No! Okay, no.
Go around this way. Where that got me sitting, man?
Well, I had to turn the iron and show up on my phone. So it's like, put it on it.
I don't know. It might be like a high A right now.
High A. All right. Hi, everybody. This is so nice. Again, hi. I love that. All right. All right, so today we are going to be talking about the scientific revolution. We're going to be taking some notes. We're going to be talking about some of the most important thinkers of that generation. And then we're going to be doing a little science experiment. So it's going to be a fun class. We're going to do a game, all of that fun stuff that you usually get when I'm teaching you guys. It's going to be a great day. Smiles everywhere. Everybody's smiling. Yawns will be accepted as smiles. Everything is good. Okay, so right now what I want you to do is I want you to just take a minute. Take 1 minute and critically think about one piece of technology that you could not live without. All right, just think about that. Whatever it may be, we'll come back to that. All right? I'll take that. Anything that did not exist 400 years ago. Did not exist 400 years ago. That you could not live without today.
Yeah.
I know your name.
No, I mean hospitals. Yeah, they use
What am I doing?
Oh yeah, 30 years. It's double. Or no, still September 21st.
Okay, what are some things that we came up with for things that we absolutely could not live without? Shower. All right, we're going to write them up here. We're going to come back to them later. Before I start writing on the board, can we all agree not to make fun of Mr. Silver's handwriting? Because he's a little self-conscious about it. Can we all just agree not to make fun of my handwriting on the board before I... All right, thank you very much. I appreciate that. All right, one, we've got the... Oh, I know. Shower. What else we got?
See, that's not even that bad. You can't even read mine.
Did everybody say shower? What else we got? Phone. All right, cell phone. Cell phone, what else?
Microwave.
Microwave. Could not live without the microwave.
Refrigerator.
Fridge. Car. Toaster. Just gonna put that up here. All right. Computers. We use computers for everything, Carolyn says. That's absolutely true. All right. So we're gonna come back to this. If you want to take notes on your Chromebooks, you can do that, but you shouldn't be playing games or anything on your Chromebooks. If I see you playing, you will not be multitasking during this lesson. I need your attention up here, all right? Everybody good with that? Dennis, be good with that? All right. So, today we are going to be talking about the scientific revolution. You have guided notes in front of you. Those will be due at the end of the class, so make sure that you're filling them out as we go. So, the scientific revolution is really going to begin with this guy, Nikolai Copernicus. He is there. That's that first guy who we're going to be talking about. Okay? So before him, everything people knew about the solar system, about the Earth, about the stars, about the sun, about the galaxy was completely wrong. It was just absolutely wrong. So everybody believed that the Earth was at the center of the universe. What do we now know is at the center of the universe? The sun is at the center of the universe. And that is going to be Copernicus's main contribution. That's what he's going to say. He's going to say the sun is the center of the universe. He has 4 aspects to his theory that completely were different than what anybody else at the time was saying. Nobody at the time was saying these 4 things but him. He says the sun is the center of the universe, and the Earth and the other planets are revolving around it. So the Earth and other planets revolve around the sun. So if everything's revolving around the sun, is the sun moving? So the sun is stationary. That's the second aspect of what he has to say. He says the sun's not moving around the Earth, everything's moving around the sun, and the sun is staying put in the center of the universe. What revolves around the Earth? The moon. So Copernicus says the moon revolves around the Earth. And the last aspect of what he had to say is that the stars that we see at night, they are significantly farther away than the sun is. So the church looks at everything that Copernicus has to say, and they said, that's ridiculous. None of that is true. None of that can be proven. These are all just theories. Of course, the Earth has life. So the Earth has to be the center of the universe. Plus, we see the sun moving. Literally, it moves across the sky every day. That's how they knew that the sun was moving, or how they thought the sun was moving. Same thing for the moon. They thought the moon was revolving the same way the planets do around the Earth and around the sun. So the church looks at everything that Copernicus has to say and essentially says, none of that's true. And Copernicus couldn't really say that his ideas were true because he couldn't prove them. He tried to prove them with some of the telescopes that they had to date, but the telescopes of the 1400s weren't exactly the ones where you could see really clearly into space until a guy by the name of Galileo Galilei comes along. And he's going to be the next guy that we need to talk about. So he starts developing these telescopes. Telescopes have been around, but he starts looking at them and he says, we need these to be better if we're going to actually learn anything about what's going on in the solar system. So he starts developing these telescopes that can help see further. And what he finds out when he develops this telescope is that everything that Copernicus had said was 100% right. Which is not very liked by the church. So in 1611, he's brought up by the Inquisition. Does anybody know what the Inquisition is? Okay. That's like the FBI of the Catholic Church. You do something that the Catholic Church doesn't like, they're going to investigate it, you're going to be brought up by counsel, you're going to have to testify, all this stuff. They're like the police officers and the FBI and the CIA. They're everything that the Catholic Church has in terms of law enforcement. So, in 1611, Galileo is brought up by the Inquisition. And Galileo, he says everything that science is a reflection of God's will. The Catholic God's will. He says everything in the universe, because Galileo is Catholic, he says everything in the universe was created by God, and that science is just figuring out exactly what that is. So he's not trying to defy the church. He's making sure that everybody knows what's going on. And the church listens, and as the Inquisition usually did, they said, we don't buy it. That's not really what's going on. You need to stop upholding Copernicus's views. You need to stop saying that what you think you've proven is correct. Let's take a vote. How many people think that Galileo listened to that and said, yeah, I'll stop? All right, how many people think that Galileo listened to that and said, yeah, there's no way I'm stopping? Okay, if you put your hands up for the second one, you're correct. Galileo heard this from the Inquisition. He said, look, what I have to say is true. If you knew that something that you had proven was absolutely 100% true, and then somebody came around and said, yeah, but you're not allowed to tell anybody about it, how would you feel? Very mad. He was mad. So he wrote this pamphlet called the Assayer. And in the Assayer, he essentially says the state and the church need to stay out of scientists' way. We have to be able to do what we have to do. Otherwise, the only truth that's going to be out there is the truth that they want us to know, and not the actual truth of what's going on. So then the Pope gets a hold of the Assayer. Let's take another vote. How many people say the Pope reads this and goes, yeah, I like this. I like what Galileo has to say. All right, and how many people think that he's going to look at it and go, hey, I don't like this very much. I don't like what he has to say. Got a few more hands for the second one. So this is actually a twist in the story, because usually popes wouldn't like it when you went against what the Inquisition said. But Pope Urban XIII, he says, I agree with Galileo. And here's his rationale. He says that God could create anything in the universe. He says that things are always changing, so maybe Galileo's right. But he contacts Galileo and he says, I need you to be respectful of other people's views as well. I know that you believe that you found the truth, but we need you to be respectful of what we have to say and what others have to say, and then we'll be respectful of what you have to say. It's that golden rule. What's the golden rule? Anybody know what the golden rule is? You guys ever heard that? Treat others how you want to be treated. Absolutely. So that's what Pope Urban XIII asked. He just asked that Galileo respect other people. Another vote. How many people say Galileo respects what other people have to say from now on, learns his lesson, and keeps on researching? How many people say Galileo does not agree with the Pope and decides, no, I'm going to go ahead and just stick to my stuff? Yeah, he doesn't want to give anybody else any credit. He doesn't want to believe what anybody else has to say. He has found indisputable proof in his mind that Copernicus was right about everything. And we now know that Copernicus was right and Galileo was able to prove it. So what we've learned from Galileo is that the most important thing that we can do in science is experiment. And that was his legacy. His legacy was experimentation. Then we get this guy by the name of Francis Bacon. He comes along and he has 3 points to what he has to say about science. He says that science should be practical. What does that mean? What does he mean that science should be practical? What does it mean when something's impractical? Not realistic. So things should be realistic. You should only do science that can be proven in some way. Don't do things that can't be proven, things that can't be tested. He says it should be instrumental. It's a second point. What do we think that means? Instrumental. What did you say, Jeremiah? Without? Without what? Okay. Along the right track, it's without complication. So it should be basic. And your third point is that it should be supported by the state. It should be supported by the state. What do I mean when I say that it should be supported by the state? Carolyn, what do I mean when I say it should be supported by the state? Meaning, in what way? They agree it's true. Or they agree that you should be researching it. They just agree that we need to look into this. So it should be practical, it should be instrumental, and it should be supported by the state. Not really a whole lot of that was what Galileo had going on, but that's what Bacon had to say about it. And we get a lot of what we do today from a combination of what Galileo had and Bacon had, and this next guy who we're going to talk about, who is Descartes. But before we move on to Descartes, we need to talk about this last detail about Bacon. And that's his legacy. He said that all of science should have this purpose: to improve humanity. That's why we do science, because we need to improve humanity. Does that make sense? Okay, so let's talk about Descartes. Now Descartes, he was very big on math. Why would he be big on math? What does math provide that logic or humans can't? Evidence. Evidence through, when you think about math, what's the first thing that comes to your head? Numbers. So numbers can't lie. Math can be proven. Math is what proves theories. He says that anything that we learn from our senses, what are our senses? What are the 5 senses? Sight, smell, taste, hearing, touch. Those are your 5 senses. Anything that we learn from those senses is something that's being judged by us. Who in here likes apples? Who in here does not like apples? I don't like apples. So you might think that something's good, I might think that something's bad, and that's because our senses are different. Our sense of taste is different. Numbers, they can't lie. So that's why he says that everything in the universe is simply things that numbers can prove. And so that's what we need to stick to in science, making sure that things can be proven and things can be testable. And so when you put these 3 influencers together, that's when we get what we call the scientific method. Just skip over Newton on your notes, we're going to come back to him. So that's the scientific method. There's 6 steps that you need to take when you're researching something. Ask a question. What do we mean when we say ask a question? That's the first step of research. So what you want to research about? What's the problem? Why do we need to be researching this? Then you need to do background research. What's background research? So research on the background of the issue. What kind of things go into the background of an issue? The past, so past research, maybe measurements, that kind of stuff. Then you need to construct a testable hypothesis. What does that mean? It has to be testable. You can test it. It has to be something that can be proven, just like we're thinking back to Descartes. He says that everything in the universe is something that can be proven. So I can say that I think the Indian Ocean is colder than the Pacific Ocean. And that can be tested. We can take a thermometer to different parts of the Indian Ocean and different parts of the Atlantic Ocean, different parts of the Pacific Ocean, whatever we want to do. That can be proven. I can't say I think the Indian Ocean is better than the Pacific Ocean. Why not? That's an opinion. That can't be tested. We can't test that one. We can survey, but that's not going to give us a definitive answer on which one's absolutely better. It's just going to tell us what a majority of people think is better. Then you have to conduct an experiment. Whose legacy was experimentation? Galileo. Galileo said that we need to be experimenting. So that's step 4 in the process. You have to experiment. Then you have to analyze that data and come to a conclusion based on it. So Newton takes these 6 steps, and that's how he comes up with the majority of his theories. One of those theories, probably the best known one, is gravity. Newton comes up with the theory of gravity. He comes up with these laws of motion. He comes up with ideas about light and color. And Newton never really cared about fame. He just cared about getting the ideas out there, which is that last step of the scientific process that you have to communicate your results. All right, does anybody have any questions about these thinkers before we move on to our activity? Yeah, we'll talk about this. Okay, so now what we're going to do is we are going to be doing an experiment. We are going to use the scientific method. We're going to use all 6 steps. We're going to analyze a problem. We're going to do background research. But most importantly, we are going to have fun. So keep smiles on your faces, please.
Wait, what is this? I'm actually clicking.
Yeah, so these are yours. These are your scientific notebooks, all right? Go ahead and write your name right here where it says name. This is a good warm-up. Okay, so today we are going to be answering this question. This is what goes on your page 1. What's the first step of the scientific method? Ask a question. So the question we're going to be answering today, why do things bounce to different heights? Very simple question. We're going to be figuring out why different things bounce to different heights. It's the only thing that's going on the page, so you can write as big or small as you want.
Repeat the question.
What's the question?
Why do different things bounce to different heights?
Answer that right here.
You don't have to answer it. We're going to answer it together. We're going to conduct experiments and all that kind of stuff. You just write it down on page 1, just like this. Why do different things bounce to different heights? So here's what we're going to be doing.
I tried to write here, and that's how.
Here's what we're going to be doing today. We have 5 different types of balls. We have a basketball, a volleyball, a ping pong ball, a golf ball, and a baseball. We're going to be bouncing all of them and seeing how high they go. And then we're going to try to figure out why some of them bounce higher than others. What are some background things that you think you might want to know before we get into this?
The weight of each item.
The weight of each item, that's crucially important. Okay, so I'm going to tell you the weight of each item, because you've asked for it, okay? So make sure you write these down. This is on page 2. This is that background research that we have to do. The ping pong ball weighs 2 grams. The golf ball weighs 45 grams.
It's what?
45 grams. The baseball weighs 149 grams. The volleyball weighs 260 grams. What is it? That one was a volleyball. The basketball weighs 700 grams. What else do we think might be important to know? Well, the height we drop it from is going to be the same for all of them. So that shouldn't have an effect on how high each of them bounce. It will have an effect on how high they bounce, but not when you compare them to each other. So since they're all going to be dropped from the exact same height, it should be constant for all of them. What else do we think might be important to know? Air pressure. Air pressure. So the air pressure that's going to be applied to them is going to be based on what? The room. They're all having the same room. What do all of them have that are different that could affect the air pressure? The air resistance. Surface area. How big they are. Alright, so I'm going to tell you how wide across each of them are. The ping pong ball is 4 centimeters in diameter. I'm giving you the diameter for all of them. So the ping pong ball is 4 centimeters. The golf ball is 4.2 centimeters. The baseball is 8 centimeters. The volleyball is 22 centimeters. And the basketball is 25 centimeters. You ready to drop these things? Is that what you said? All right. First, before we experiment, before we do number 4, what's number 3? So we've done our background research. We know how much everything weighs, and we know the surface area. What's step 3 in the scientific method? Hypothesis. You have to construct a hypothesis. That hypothesis has to be what? Testable. It has to be a testable hypothesis. So, we're going to test it. So I want you to guess, make an estimation. Which one's going to bounce the highest? Then the second highest, third highest, fourth and fifth. Make a guess based on the background information that you've already seen. The background information that you have on page 2. So on page 3, you're going to write your hypothesis, write your rankings.
How high you drop?
I'm right here. So it'll be set up right here, and then I'll drop it.
I don't know, man. This is kind of hard.
You're not going to be graded on whether or not you guessed these accurately, by the way.
Baseball bounce very much.
And also on your page 3 on that hypothesis, write what you think the most important factor is going to be in what makes something bounce high. Could be weight, could be size, could be what it's made out of. Just take a guess as to what you think the most important thing is going to be.
You know what? I don't have any.
That makes more sense.
Could be air pressure. Yeah, we're going to go ping pong to basketball. Other way around. All right, take 1 more minute to finish up your hypothesis, then we're going to test these.
I saw you this morning with basketball. I was finna say, I'm that
Do a
one.
quick check on the air pressure.
Yeah, I'm a little, I'm one of those grandfathers, that come through, shoot a hit.
Let's take another 30 seconds. So you write your rankings on how high you think things are going to bounce, and then what you think the most important factor will be. So size, weight, what it's made out of, air pressure, whatever you think is going to be the most important thing in determining how high something's going to bounce.
Like it'd be a little bit down.
No.
I swear to God. No, I wouldn't say it was gonna be like 30. It's like a little down. So you drop it just like that.
Yep. I'm not putting any pressure on it. Just a straight drop, free fall. All right, is everybody ready to start? Does everybody have their hypotheses done?
Yes, let's go.
All right. So here's how this is going to work. I'm going to drop it. I'm going to put this piece of tape where I see its highest point was. And we're going to measure how high that was, and you're going to record how high it bounced in your notebook. It's down here.
On page 4?
All right, everybody ready? All right, that's where that one bounced to. I've got that one for 44 inches.
44 inches.
44 inches for your ping pong ball.
You want to put this down?
Yes, so this is going on your page 4. This is the experiment. So while you're doing the experiment, these scientists would take notes. Take notes about the experiment. This is all part of phase 4 of the scientific method.
Softball jump.
Is everybody ready to move on to the golf ball? We have 44 inches for the ping pong ball. So that one went up to about here.
Just a little bit. That's okay.
All right, putting it right there. All right, so that is 63 inches.
Yeah.
Golf ball went 63 inches. So we know right now, golf ball went higher than ping pong ball. Even though they're roughly the same size, the golf ball went higher than the ping pong ball. What does that tell us? That the golf ball is heavier. What else does that tell us about our question? So they're the same size, but one bounced a lot higher than the other.
I just thought about that.
So if two things are the same size, but one bounces 20 inches higher than the other one, what does that tell us doesn't matter? The size doesn't seem to matter so far, right? All right, so let's keep it going. So make sure that you're thinking critically about all of these as we go. Okay, so we're gonna do baseball now. Ready? Put that one right there. 25 inches. Baseball, 25 inches.
I guess that one right.
All right, ready? Everybody ready for the volleyball? All right, 51 inches. "51 inches. All right. All right. Does everybody have the first four all recorded? How high did our ping pong ball bounce? How high did our golf ball bounce? How high did our baseball bounce? How high did our volleyball bounce? How high do we think the basketball is going to bounce? 92,000 inches.
68.
It's gonna shoot out the roof.
No, I'm gonna guess like.
I hope not. Can't afford that.
No, like
All right.
57. 57 is
57 is the guess. Do we have any other guesses? Let's see.
54.
That might be a bit over budget.
60. Or 60 going once, going twice. All right, ready?
I think it's 40 something.
3, 2, 1. So now right there.
That's 54.
53.
46.
54.
That's 54 inches.
Yeah, I'm cool.
You know what? Volleyball's not sexy.
I told you.
My name's DeMarcus and I play basketball.
How many is
You know, I didn't know golf
So,
bounces.
How high did our ping pong ball bounce? How high did our golf ball bounce? How high did our baseball bounce? How high did our volleyball bounce? How high did our basketball bounce? Okay, so on your first page, you have your question. You have the question that we asked. Then we did background information. We found out the weight and the size of everything that we are going to be testing. Then, on page 3, we guessed how high is everything going to bounce. Made rankings. Then, we recorded how high everything bounced. What is step 5? You have to analyze the data. So this part you're going to do on your own. Look over your page 2, your page 3, and your page 4. You need to look at the things that you researched to start on page 2. See what mattered and what didn't. So we already said that the size didn't appear to matter. Go back and look at the weight. Then on page 5, I want you to tell me what actually matters now that we've tested it. What things should we have had background research on that we didn't? Look at your data and make a new guess. Make a new guess on what you think the most important thing in what a ball, on how high a ball will bounce is. It's page 5. Do this on your own. Take 3 minutes. This is on page 5. Look at all the results. Look at the background research. Look at your hypothesis. And look at the experiment we did. So pages 2 through 4. This is being done on your own, guys.
Air, temperature,
velocity, background, acceleration of gravity.
Oh, thank you. They got a bunch of
I have it right now. You know, if you give me a calculator, I could punch in the numbers, you know what I'm saying? Punch in the numbers, see how fast the velocity
Okay, so has everybody done page 5?
Yes.
Yeah.
Have you looked at your results? Have you made a new prediction on what you think will affect how high something bounces?
Yes.
The new thing that you think is most important.
Yes.
Okay, so that's step 5. You analyze the data. What's step 6?
Communicate the results.
Communicate the results. So, it wasn't enough that these scientists knew what was happening. Galileo knew what was happening, and the church said, stop telling people about it. Descartes said, you have to be able to tell people about it for the purpose that Bacon said of improving humanity. It's not enough to just do the experiment and know it. You have to be able to communicate those results. So, for the next 5 minutes, it needs to be quiet, and you're going to write me a letter on page 6. Explain what you just did, and explain your new hypothesis on what makes something bounce higher than something else. That's what's going on page 6. Need you to write me a letter. Communicate the results of our experiment to me. Take 5 minutes. It needs to be quiet so everybody can really analyze the results of the experiment.
Analyzation complete.
It's on page 6. You write your letter. Just sum up everything you did. Tell me what your new hypothesis is. The new thing that you think is going to make something bounce. If you look back at your page 3 and you look at your hypothesis and you still think that that's right, you can tell me that in your letter.
Yeah, I'm trying to think of. I was right about the last.
If you look at it and you don't think it's right anymore, tell me what you do think is right and why. Take another 2 minutes and finish up your letters. aside for 1 second. We're going to come back to it. Still have people working on their letters, guys. It should still be quiet. We still have people working on their letters. All right, let's look up here. Why do you think I asked you about this list at the beginning of class, these 6 things? Why do I think I asked you that question? Some things you could not live without that didn't exist 400 years ago. What about everything we did today? We talked about the scientific revolution. We talked about experimentation, the scientific method.
Those things wouldn't exist with modern science.
These things would not exist if it weren't for modern science. Every single one of these things are here because they were tested through this process. This is how we test everything for 400 years. We ask a question. Let's take a look at one of these. Let's take a look at cell phones. We ask a question. 100 years ago, if you wanted to use a phone, you had to go into a room, and there's a wooden box that you have to call somebody. And when you want to call somebody, you have to pick up the phone, you have to talk to an actual person, tell them who you want to talk to, and they exchange all these wires and some board that get you to talk to somebody else, and the whole thing takes like an hour. So the question was, how do we make that simpler? How do we take all of that and put it in somebody's pocket? So they did background research. They figured out how these things work and how that process can be condensed into something smaller. They made a hypothesis. They tested it. It probably didn't work the first time, so they retested it. They redid their hypothesis until they found one that works. And now 100% of the people who are in this room right now have used a phone. And probably have one in their pocket right now. Everything we have today, you look around this room, everything that you see is here because of what you just wrote in here. Not because balls bounce, but because of the scientific method. So that's why this is so important for us to know and learn, and that's really the impact of the scientific revolution, is this right here. So the last thing I want you to do is I want you to open these up to page 7. That's your last page. Open up to page 7. And tell me why the scientific revolution matters. Tell me what's important about the scientific revolution. If you were going to teach this class, what's something that you would absolutely make sure that you told your students? When you're done, I'm going to come around and collect these, but please stay quiet, because we do still have people working. have people working on their page 7, so please be respectful of those who are still working. Right now, I'm just taking these up.
This is our science that's true discoveries. Those are rare. You know what I was thinking about the other day? You know those like materials that use Google
Yeah, I did the first one, but the second one.
like things you can do about.
Yeah, I know, but the second one. When I would do something, and it was wrong, right? And it was right. Like, literally, it was 100% right.
They're trying to make this project where there's an entire console inside the controller. So like you put the controller to your
Yeah, I tried like a bunch of different, but like Mark, what do you think it was? Yeah. And then also, yeah, and it was just like
Get
1
a
out of
Google
4.
router while you're at your Google console in your Google.
You can put the guided notes in your binders. I'm not going to write those today.
Really, it means I'm right.
You know, I think Google is just kind of monopolized and say, oh, dude, we're doing good, and then they take it over.
What?
It's Google and Amazon right now.
Guys, have a great day.
Companies, you know, I'll start
Working better than.
You know what it is? What happens is Google is monopolizing everything, right? And then the people that don't trust Google because they recognize it's monopolizing everything are getting monopolized by Amazon.
Guide notes or...
I've never used Amazon. I've been using eBay.
Well,
eBay, Amazon is just the shopping website. So eBay, they own like half of everything. If I want, you know, Amazon owns Twitch.
Take a picture with your phone.
Amazon Prime, guys. Yeah, come on. Amazon Prime, same thing. It actually is. I'm Amazon Prime. I dropped my pencil across the room. Oh,
Or did you get everything done?
no.
Good.